In this screencast, we'll see how hypothesis testing works, and we'll use Statkey to do it, but we'll use this as an example to try to understand hypothesis testing a little more. So we'll start with this question. Is the average weight of adult men in the United States more than 185 pounds? So a medical researcher might want to know this, or a demographer, or people studying obesity, comparing what it is now to what it was 20 years ago. But whatever the reason for wanting to know that, we'll take that as a research question. So we're comparing two possibilities, the null and the alternative. The null hypothesis is that the mean is 185 pounds. It's not more than. So let's just get the right symbols for that in there. Mu is a symbol for the mean. Mu equals 185. And the alternative hypothesis, so this is what we need evidence before we'd be willing to believe. We need evidence that the mean is greater than 185. So those are the two choices. And for right now, you should always think of the null hypothesis as coming with an equal sign. When we're talking about proportions or means, the null hypothesis always has an equal sign. And the alternative is the thing that we would like to know whether we have evidence in favor. So we need a reason to believe that the mean is not 185, that in fact it's more than 185. So this is step one in hypothesis testing, to identify the null and alternative hypothesis. Step two is to find the p-value. So the p-value is the answer to this question. So the p-value answers the question. I'll just put this in red. What is the likelihood of getting data as extreme as we did if the null hypothesis is correct? So we're going to look at the weights of the men in our health data and look at their average weight. In fact, let's do that now. So here's our health data. Here's the weight of, we're in the men sheet, so here's the weight of men. Let's copy them, and let's go to Statkey, and for one quantitative variable, and put in all those men. And they have a mean of 189.674. So, okay, great. That's more than 185, but it's not a lot more. And maybe it's just random chance. Maybe if we'd picked a different sample, we would have gotten less than 185. And maybe we picked a third sample would be exactly or very, very close to 185, even closer. So in our sample, the mean is more than 185, but we're not interested in what's true in our sample. We're interested in what's true in our population. Is the population mean more than 185? And so the p-value is the answer to this question. If the population mean is exactly equal to 185, how surprising would it be to get a sample mean of 189.674 on a sample this big? So here's how we do that in Statkey. We go to randomization hypothesis test for a single mean, enter that same data, and over here we have the original data, original sample, the mean 189.674. And now we set our null hypothesis, the thing we're comparing against, to 185. And then we're going to ask Statkey to generate some samples. So let's just generate one sample for starters. So that one sample, you see it over here, it had a mean of 185.89. And what Statkey is doing, it's taking our original data and it's shifting it down so that it has mean exactly 185. It's making our original data look like our null hypothesis. And then it's generating bootstrap samples of size 478 from that. What this is going to do for us when we generate 1,000 samples, it lets us see how surprising it would be in a population where the mean actually was 185, how surprising it would be to get a sample mean as large as we did, 189.674. And that answer to how surprising, that's the p-value. So each dot in this dot plot represents the mean of one sample from a population where the mean actually is 185. So the computer has created a universe where the parameter, the weight, is 185, and then it's giving us samples of size 478. And the samples, or the population it's created, looks a lot like our original data, so that's why this is a valid process. It looks as if it's spread out in the same way original data is spread out. So each of these dots represents the average of 478 people, 478 men from this universe where the mean is actually 185 for the whole population. And I want to know how often we got a number in these samples as high as 189.674. Notice that it happens sometimes. Here's a 190. But how often? So to find out exactly how often, we look at the right tail, and we change this on the x-axis. We change that to our actual original sample mean, 189.674. And that gives us a p-value, that's what this number is, of 0.004. So in the 1,000 samples that it was created in this universe, only 4 of them, 0.4%, were as large as the one we got. So the conclusion is that in a universe where the actual population mean is 185, there's only a 0.4% chance of getting a sample mean as large as the one we got from our sample, which makes us think that our sample didn't come from this universe, did not come from a universe where the mean was 185. So that's how we get the p-value. P-value equals 0.004. And typically, when we get a small p-value, we reject the null hypothesis. So step 3 is to make a decision. Do we reject the null hypothesis or do we not reject it? And those are the only two choices, to reject or to not reject. And when the p-value is small, we don't reject. Sorry, when the p-value is small, we do reject. How small? Typically, especially in an introductory stats class, how small is any number less than 0.05. So something that happens less than 5% of the time is considered statistically significant. So decision, we reject the null hypothesis. So that means it's as if we're throwing this away. We're throwing the null hypothesis away. And our conclusion in plain ordinary English is that we have evidence that the alternative is true. Conclusion, well, that's not plain ordinary English. This is. We have evidence that the mean weight of men is more than 185 pounds. And then finally, the rationale. Why did that p-value lead to that conclusion? If the mean weight of men were 185 pounds, there would only be a 0.004 probability of getting a sample mean as large as or larger than 189.674 that we found in our sample. So step 4 is the conclusion. And step 5 is the rationale. So we start with a research question. Set up our two alternatives. It's either equal to 185 or greater than 185. Then we find the p-value, which tells us how surprising the data we actually collected would be if the null hypothesis were correct. And when the answer is very surprising, we say, okay, the null hypothesis is not correct. We have evidence that the alternative is true. Because if the null hypothesis was correct, there would only be that p-value, that small p-value probability of getting data as extreme as we got. So that's just one brief example, show how to do it in Statkey, and we'll spend quite a bit of time in class practicing these and sort of getting the hang of them, because this is probably the hardest thing in the course for students.